Hello there, and welcome to the Snoozy Explorer. Tonight, we are returning once more to Paris, to a city that existed in the gentle glow of gas lamps and the quiet clatter of horse-drawn carriages on cobblestone streets. We are going to watch very slowly and very calmly as something extraordinary takes shape in the heart of this city. Not through drama or spectacle, but through the patient, methodical work of people who understood that important things cannot be rushed. This is the story of the Eiffel Tower, told not as a triumph or a controversy, but simply as work being done, piece by piece, rivet by rivet, day after quiet day. There is nothing you need to remember from this story. There are no tests, no questions, no details you must hold on to. This is simply a journey through time, a chance to watch as iron is shaped and lifted and joined together, as a structure grows slowly from the ground toward the sky, as Paris adjusts to something new appearing in its midst. All you need to do is breathe slowly, allow your body to settle into comfort, and let your mind drift through this quiet history. Let's begin. Imagine Paris on an evening in the late 1880s, as daylight fades and the lamplighters move through the streets. They carry long poles with flames at the tip, reaching up to ignite the gas lamps that line the boulevards and smaller streets. One by one, the lamps bloom into soft yellow light, creating pools of illumination in the gathering darkness. The light is warm and flickering, not harsh like electric lights would later be, but gentle, casting soft shadows that move slightly as the flames dance in their glass enclosures. The streets are quieter than they will be in future decades. There are no automobiles yet, no engines rumbling and honking. The sounds are organic, the clip-clop of horse hooves on stone, the creak of carriage wheels, the murmur of voices from cafes where people sit at small tables watching the world pass by. Occasionally, a street vendor calls out, selling chestnuts roasted over a small brazier, the smell of smoke and roasted nuts drifting on the cool evening air. The pace of life is slower, measured by the limitations of horse-drawn transport and human walking speed, by the cycle of daylight and darkness that electric lighting has not yet extended indefinitely. The buildings of Paris are predominantly stone, built to last, their facades decorated with carved details and ornamental ironwork on balconies. Most buildings are 4 to 6 stories tall, creating a relatively uniform skyline interrupted only by church spires and domes. The city spreads horizontally rather than reaching upward, its architecture reflecting centuries of tradition where height was limited by the capabilities of masonry construction and by aesthetic preferences that valued harmony and proportion over dramatic vertical statements. In the cafes and salons, people discuss the coming World's Fair, the Universal Exposition planned for 1889 to commemorate the centennial of the French Revolution. Such expositions have become regular events in major cities, opportunities to showcase technological progress, industrial capability, and cultural achievements. Previous fairs have featured impressive structures, enormous exhibition halls, glass pavilions, innovative demonstrations of new technologies. The 1889 exposition will need something equally memorable, something that demonstrates France's position at the forefront of engineering and design. Various proposals have been discussed. Some suggest elaborate gardens suspended in the air, others propose massive fountains or illuminated displays. There is talk of buildings that would house exhibitions of arts and industry, grand halls where visitors could marvel at the latest inventions and artistic creations. But one proposal stands out for its ambition and its strangeness. A tower, made entirely of iron, rising 300 meters into the air, taller than any structure yet built by human hands. It seems almost absurd, this idea of a metal skeleton standing in the heart of Paris, serving no practical purpose except to demonstrate that it can be built. The man behind this proposal is Gustave Eiffel, though the initial design came from engineers in his firm. Eiffel is 55 years old in 1887 when construction begins, an established engineer known for his bridges and viaducts, for his understanding of how iron behaves under stress, for his ability to calculate precisely what is needed to make structures stand safely. He is not an artist in the traditional sense, not someone who sketches beautiful buildings for their aesthetic appeal. He is an engineer who believes that structures designed according to sound engineering principles will possess their own kind of beauty, a beauty that comes from honesty and efficiency rather than from applied decoration. Eiffel's approach to design is methodical and careful. He does not sketch wildly or improvise. He calculates, measures, tests his assumptions, revises when necessary. His notebooks are filled with numbers and diagrams, with stress calculations and load distributions, with careful considerations of wind forces and thermal expansion. He thinks about how materials will behave in different conditions, how connections will transfer forces, how the structure as a whole will respond to the various challenges it will face. This careful thinking takes time, but it reduces risk. When construction begins, he wants to be confident that what is being built will stand, will endure, will not collapse or fail in ways that could injure workers or disappoint those who have invested in the project. The tower that Eiffel designs is not a solid structure but a lattice, an open framework of iron beams and struts arranged in patterns that provide strength while minimizing weight. This lattice serves multiple purposes. It is efficient, using less material than a solid tower would require, making the structure lighter and less expensive. It allows wind to pass through rather than creating a solid barrier that wind would push against with maximum force. And it distributes loads throughout the structure, so that no single element is overstressed, so that the tower acts as an integrated system rather than as separate components that might fail independently. The design calls for over 18,000 individual iron pieces, each one unique, designed for a specific location in the structure. There are no standard, interchangeable parts. Every beam, every plate, every bracket is custom-made to fit exactly where it needs to fit. This specificity means that fabrication must be extremely precise. If a piece is made incorrectly, if its dimensions are wrong or its holes are misplaced, it will not fit during assembly, and the entire construction process could be delayed while corrections are made. Precision in fabrication is not optional. It is essential. The blueprints that Eiffel's team produces are detailed beyond what most people would imagine necessary. They show every piece from multiple angles, specify dimensions to the millimeter, indicate hole positions for rivets with exacting precision, provide notes about materials and assembly sequences. These drawings fill large sheets of paper, covered with lines and numbers and annotations, each sheet documenting a small portion of the overall structure. Together, the drawings constitute a complete instruction manual for building the tower, a guide that workers will follow as they fabricate pieces in workshops and then assemble them on site. Looking at these drawings requires patience and concentration. They are technical documents, not artistic renderings. They do not show what the tower will look like to a casual observer. They show how it will be built, how pieces will connect, what forces will flow through each element. This information is what matters for construction. Aesthetics will emerge from following these technical specifications carefully. The tower will be beautiful because it is well engineered, not because beauty was added as a separate consideration. In workshops located in Levallois-Perret, a suburb northwest of Paris, the work of fabricating the iron pieces begins. These workshops are large industrial spaces filled with the tools and equipment needed for working metal. There are furnaces for heating iron, making it soft enough to shape. There are hydraulic presses for bending metal plates to exact curves. There are drilling machines for making holes, their precision ensured by careful setup and constant checking. The workshops are noisy during working hours, filled with the sound of metal on metal, the hiss of steam-powered equipment, the calls of workers coordinating their efforts. The iron arrives at the workshops as standard shapes, beams, plates, angles produced by iron mills. These raw materials are then cut to length, shaped to match the specific requirements of each unique piece, and drilled with holes in precise locations. The cutting is done with saws and shears, the shaping with presses and hammers, the drilling with machines that hold the metal steady while rotating drill bits bore through it. Every operation requires attention and skill. The workers performing these tasks have trained for years, learning how metal behaves, how tools work, how to achieve the precision that the tower demands. Each piece, as it is completed, is marked with an identifying number. This number corresponds to a specific location in the tower, linking the physical piece to the drawings that show where it belongs. Without this numbering system, the thousands of pieces would be impossible to organize and assemble correctly. With it, the complexity becomes manageable. Each piece has its place, its identity, its role in the larger structure. Workers in the fabrication shops do not need to understand the entire tower. They need only to make their assigned pieces correctly, trusting that someone else is coordinating the overall effort. The work in the workshops proceeds through 1887 and 1888, continuing throughout the period when the tower is being assembled on site. Fabrication and construction happen in parallel, with completed pieces being transported to the Champ de Mars as they are needed. This coordination requires careful planning, ensuring that pieces arrive neither too early, which would create storage problems, nor too late, which would delay construction. The flow of materials from workshop to site is steady and continuous, a logistical operation that runs quietly in the background of the more visible work of assembly. Transportation from the workshops to the construction site is by horse-drawn wagon. The pieces are loaded carefully, secured to prevent shifting during transport, then drawn through the streets of Paris at the patient pace of horses walking. The wagons make their way through urban streets, navigating around other traffic, pausing when necessary, eventually arriving at the Champ de Mars where the tower is rising. The journey takes time, but there is no way to rush it. The horses walk at the speed they walk. The wagons carry what they can carry. The iron pieces arrive when they arrive. At the construction site, the pieces are unloaded and sorted, organized according to where they will be used. Workers check the identifying numbers against assembly drawings, ensuring that the right pieces are available when needed. The site is organized into zones, with materials staged near where they will be installed. This organization reduces the time workers spend searching for pieces, allows work to flow more smoothly, prevents confusion that could lead to errors. The visible work of building the tower is supported by this invisible work of logistics and organization, the careful management of thousands of pieces and the coordination of many workers. As evening falls on the construction site, as the day's work ends and workers depart, the partially built tower stands quiet in the gathering darkness. The iron framework catches the last light of day, creating silhouettes against the sky. The structure is not yet tall enough to dominate the skyline, but it is substantial enough to announce its presence, to signal that something significant is being built. Guards remain on site through the night, watching over materials and equipment, ensuring that nothing is stolen or vandalized. The site is peaceful in darkness, still and waiting for morning when work will resume. Paris settles into its evening rhythms around the construction site. Cafes fill with customers. Theaters present their performances. People walk through streets illuminated by gas lamps, going about their lives, occasionally glancing toward the Champ de Mars where the tower is growing, wondering how tall it will become, whether it will truly be as impressive as promised. Most Parisians have not yet formed strong opinions about the tower. It is still abstract, still incomplete, still difficult to judge. They wait, watch, and wonder what will emerge from the construction site. The foundation work for the tower began months before any iron was raised into the air. This groundwork was essential but invisible, work that would be buried and forgotten once construction progressed, yet work that everything else depended upon. A tower 300 meters tall exerts enormous downward force on the ground beneath it. This force must be distributed across foundations that reach down to stable soil or bedrock, anchoring the structure so firmly that wind and weather cannot shift it, cannot cause it to settle unevenly or tip dangerously. The site at the Champ de Mars presented challenges because it was near the Seine River, meaning groundwater was present not far below the surface. The soil was not uniformly stable. Engineers needed to excavate down to more solid layers, then build massive concrete foundation blocks that would support the tower's 4 legs. The excavation work was done largely by hand, workers with shovels and picks digging holes that were tens of feet deep, removing soil that was hauled away in carts. It was laborious work, repetitive and unglamorous, the kind of construction labor that has changed little across centuries. As the excavations deepened, water became a problem. Groundwater seeped into the holes, collecting at the bottom, making it difficult to work. Pumps were installed to remove water faster than it could accumulate. These were steam-powered pumps, running continuously, their steady rhythm providing the soundtrack to the excavation work. The pumps needed constant attention, fuel to keep their boilers hot, monitoring to ensure they did not fail and allow the excavations to flood. Workers tended them around the clock, understanding that if the pumps stopped, work in the holes would become impossible. For the two foundation pits closest to the Seine, the water problem was particularly severe. These excavations were at lower elevation, closer to the river, and water infiltration was heavy. Eiffel decided to use compressed air caissons for these foundations, a technique he had experience with from bridge building. Caissons are large metal chambers that are sunk into the ground with workers inside excavating material beneath them. Compressed air is pumped in to keep water from entering, creating a dry workspace below the water table where men can dig without drowning. Working in compressed air caissons was difficult and uncomfortable. The air pressure inside had to be significantly higher than normal atmospheric pressure to keep water out. This high pressure created physical stress on workers' bodies. They could work only for limited periods before needing to exit and depressurize slowly to avoid caisson disease, the painful and potentially fatal condition caused by nitrogen bubbles forming in the blood when pressure is reduced too quickly. The workers who performed this labor were paid more than surface workers, compensation for the discomfort and danger they endured in the compressed darkness beneath the earth. The caisson work proceeded slowly through early 1887. Workers inside the pressurized chambers dug out soil, which was removed through airlocks. As material was excavated, the heavy metal caissons sank deeper under their own weight. When the caissons reached solid ground, the excavation stopped, and the chambers were filled with concrete, creating massive foundation blocks that extended deep into the earth. These blocks would bear the weight of the tower's legs and resist any movement or settling that could threaten the structure's stability. The two foundation pits farther from the river could be excavated with conventional methods, keeping water under control with pumps. Once the pits reached the required depth, concrete was poured directly, building up the foundation blocks layer by layer. The concrete was mixed on site from cement, sand, gravel, and water, then transported in wheelbarrows to where it was needed. Workers spread and leveled the concrete, tamping it down to remove air pockets, ensuring that each layer was dense and uniform. Each layer was allowed to cure before the next was added, the concrete hardening over days through chemical reactions that generated heat and transformed the wet mixture into stone-like solidity. Pouring concrete in large volumes required coordination and patience. The work could not be rushed. Concrete that was poured too quickly or not allowed to cure properly would be weaker, might crack or fail under load. The foundation work thus proceeded in stages, with waiting periods built into the schedule. Workers prepared the next sections while waiting for previous pours to cure, maintaining progress while respecting the time that materials needed to achieve their proper strength. This rhythm of work and waiting, of activity and patience, characterized much of the tower's construction. While concrete cured, metal anchor bolts were embedded in the top of each foundation block. These massive bolts, each weighing hundreds of pounds, would secure the iron legs of the tower, preventing them from sliding or shifting. The bolts were positioned precisely according to design drawings, their placement critical because the iron framework would be built to fit these anchor points. Workers used surveying instruments to verify positions and alignments, checking and rechecking before the concrete hardened permanently around the bolts. Errors at this stage would create problems later that would be difficult or impossible to correct without demolishing and rebuilding the foundations. The foundation work took months, continuing through the winter and spring of 1887. For much of this time, visitors to the Champ de Mars saw only holes in the ground, piles of excavated soil, pumps running continuously, workers moving about in muddy conditions. There was nothing dramatic or impressive about the scene. It was simply construction work, dirty and tedious, entirely preliminary to the tower that would eventually rise. Yet this groundwork was absolutely essential. The tower would stand because these foundations held it. The calculations and careful construction that went into the underground work were as important as anything that would follow above ground. By summer 1887, the foundations were complete. 4 massive concrete blocks stood at ground level, positioned exactly where the design specified, with anchor bolts protruding from their tops ready to receive the iron legs of the tower. The excavations had been filled in around the foundations, the site leveled and prepared for the next phase. The pumps were shut down, their work complete. The caissons remained underground, sealed with concrete, permanent fixtures beneath the Champ de Mars that would never be seen again but would forever support the tower above them. The foundations could not be photographed in any meaningful way. They were beneath the ground, invisible once covered, but their solidity was felt in everything built upon them. The tower would rise confidently, without settling or shifting, because the foundations were properly done. This is often the nature of essential work: invisible, unglamorous, easily overlooked, but absolutely necessary. The Eiffel Tower began not with iron rising into the sky but with concrete sinking into the earth, with men working in mud and compressed air to create the solid base on which everything else would rest. With foundations in place and iron pieces arriving from the workshops, the actual assembly of the tower could begin in July 1887. This visible work, the part that would be photographed and written about, proceeded according to a carefully planned sequence. The tower would be built in sections, each one completed before the next began, ensuring stability at every stage. Nothing would be left unsupported or unfinished. Each day's work would leave the structure in a stable condition, able to withstand wind and weather until work resumed the next morning. The first section extended from ground level to the first platform, approximately 57 meters high. This section was the most complex structurally because it included the 4 separate legs converging from their wide spacing at the base toward their meeting point at the platform level. Each leg was a massive iron framework, curving inward as it rose, requiring careful alignment to ensure that all 4 legs would meet precisely at the platform. Any error in positioning, any deviation from the design geometry, would compound as the legs rose, potentially making it impossible to connect them properly at the platform level. Construction of each leg began at its foundation anchor point. The first pieces were massive iron girders, weighing several tons each, that were bolted to the anchor bolts embedded in the concrete foundations. These initial pieces had to be positioned exactly according to the design, as their position would determine the alignment of everything built above them. Workers used surveying instruments to verify positions and angles, comparing actual measurements to what the drawings specified, making adjustments using jacks and wedges until everything matched within acceptable tolerances. As each leg began to rise, temporary wooden scaffolding was erected alongside to support workers and materials. This scaffolding was substantial, built strongly enough to carry the weight of iron pieces, tools, workers, and the various equipment needed for assembly. The scaffolding rose in stages, extended upward as the iron framework climbed higher, then disassembled and moved up again as each section was completed. It was temporary infrastructure, destined to be removed once the tower was finished, but essential during construction. Without it, workers could not have reached the work areas safely or positioned the heavy iron pieces accurately. The assembly work was performed by teams of experienced iron workers, men who had skills in reading technical drawings, handling heavy materials in confined or elevated spaces, and making structural connections that would need to be strong and permanent. Each team typically included 4 men working in coordinated roles, positioning pieces, inserting temporary bolts to hold things in place, and preparing for the permanent connections that would be made with rivets once everything was properly aligned. Lifting heavy iron pieces to increasing heights required cranes and hoisting equipment positioned strategically around the site. The cranes were steam-powered, their boilers producing the pressure that drove hydraulic cylinders or turned winch drums that pulled cables. The cranes could lift loads weighing several tons, raising them slowly from ground level to wherever they were needed on the growing structure. Crane operators needed to be skilled and attentive, controlling the lifts carefully to avoid swinging loads or sudden movements that could damage materials or endanger workers below. As pieces were lifted into position, workers guided them using ropes and long poles, preventing them from colliding with the structure or swinging dangerously in wind. Once a piece was roughly in position, it had to be aligned precisely with the pieces it would connect to. This alignment work was painstaking, requiring patience and small adjustments. Workers used jacks and wedges to shift pieces by millimeters until bolt holes aligned perfectly. They checked alignment with measuring tools and by sighting along edges, comparing actual positions to what the drawings showed. Only when everything matched exactly were permanent connections made. The permanent connections were rivets, the time-tested method for joining iron structures. A rivet begins as a solid metal rod with one head already formed. It is inserted through aligned holes in the pieces being joined, with its shaft protruding on the far side. The shaft is then heated in a portable forge until it glows red-hot, making it soft and malleable. While still hot, it is hammered or pressed to form a second head on the far side, clamping the pieces tightly together. As the rivet cools, it contracts, pulling the pieces even tighter and creating a connection that is extremely strong and permanent. Riveting was skilled work performed by specialized teams. One worker, called the heater, tended a small forge where rivets were heated to the correct temperature. When a rivet was ready, glowing orange-red, it was pulled from the forge with tongs and thrown to another worker, the catcher, who caught it in a metal bucket and quickly positioned it in the hole to be filled. A third worker, the holder-up, used a heavy tool to back the rivet from one side, while a fourth worker, the driver, hammered the protruding shaft with powerful blows to form the second head. The entire operation had to be done quickly, while the rivet was still hot and soft. It required practiced coordination among team members who had worked together long enough to anticipate each other's movements. The noise of riveting was intense and constant during working hours. The hammering rang across the construction site and could be heard throughout the surrounding neighborhood, a rhythmic metallic clanging that announced the tower's growth to all of Paris. Each rivet driven represented a permanent connection, a small but essential contribution to the structure's integrity. By the time the tower was complete, over 2.5 million rivets would have been driven, each one placed by hand, each one hammered while hot, each one cooling and contracting to lock pieces firmly together. As the four legs rose toward the first platform, maintaining their proper alignment became increasingly critical. The legs were curving inward as they climbed, following the tower's distinctive tapered shape. They had to converge at precise points at the platform level where they would be connected by the horizontal beams that would form the platform structure. If the legs were not positioned exactly right, these connections could not be made without forcing pieces together or leaving gaps. The precision required was extraordinary, especially considering that the work was being done outdoors, exposed to temperature changes that caused metal to expand and contract, and to wind that could shift partially assembled sections. To maintain alignment, workers constantly checked measurements, comparing the actual positions of the legs to what the drawings specified. They used long measuring tapes, surveying instruments, and plumb lines to verify that each leg was where it should be. When measurements revealed that a leg was slightly out of position, adjustments were made using hydraulic jacks that could push or pull sections by small amounts. These adjustments were made carefully and gradually, moving the iron framework in tiny increments until measurements confirmed that alignment was correct. The use of hydraulic jacks for alignment was innovative and essential. The jacks could exert enormous force, enough to shift iron structures weighing many tons, yet they could be controlled precisely, extending or retracting by millimeters. Workers operated the jacks by pumping handles that drove hydraulic fluid into cylinders, slowly building pressure that moved a piston attached to whatever needed shifting. The process was slow but reliable, allowing adjustments that would have been impossible with simple mechanical equipment. Once alignment was achieved, temporary supports held everything in place while permanent connections were made. The most challenging moment in the first section's construction came when the four legs finally reached the level of the first platform. This was the point where independent vertical structures had to connect to form a unified whole. If the alignment was not perfect, if the legs did not meet at exactly the right points, the platform structure could not be assembled properly. Eiffel and his engineers were confident in their calculations and fabrication, but confidence is not certainty. The final positioning involved careful use of jacks and wedges, adjusting each leg minutely until all four were precisely where they needed to be. When the connections were finally made and the first platform structure was complete, it represented a major milestone. The four separate legs were now joined into a single integrated structure. The tower could stand without its temporary scaffolding, though scaffolding remained in place as work continued upward. The most difficult and uncertain part of the construction was complete, the part where failure had seemed most likely. What had been four complex curved structures rising independently from separate foundations was now one tower, its first major section finished, stable, and ready to support the sections that would be built above it. The first platform itself was substantial, a horizontal iron framework 60 meters above the ground, forming a space large enough to eventually hold restaurants and viewing areas for visitors to the exposition. During construction, it served as a work platform, a base from which the next section of the tower could be built. Workers could now ascend to this level and begin assembling the second section, which would rise from the platform to the second platform at 115 meters. The work would continue, section by section, until the tower reached its full height. Work on the first section had taken approximately a year, from July 1887 to July. Breaks were scheduled for meals and rest, essential for maintaining energy and concentration through long workdays. Workers brought food from home, simple meals that could be eaten without preparation, or they purchased food from vendors who set up near the construction site selling bread, cheese, sausages, and wine. They ate sitting on beams or platforms if they were high on the structure, or in sheltered areas at ground level if they had descended for their break. These meal breaks were also social time, opportunities to talk and joke, to complain about foremen or difficult tasks, to share news from home, to build the camaraderie that made the work more bearable and that created bonds among men who depended on each other for safety. Weather affected the work significantly and unavoidably. In winter, cold made metal painful to touch with bare hands, requiring workers to wear gloves that reduced their dexterity and made fine work more difficult. Ice and snow made surfaces slippery and hazardous, requiring extra caution and sometimes forcing work to slow or stop until conditions improved. Winter days were short, with less daylight available for work, though occasionally work continued into darkness with the aid of torches and lanterns when schedule pressures demanded progress. In summer, heat made physical labor exhausting, and the iron surfaces of the tower became almost too hot to touch in direct sunlight. Workers sought shade when they could, but much of the structure was fully exposed, offering no relief from the sun. Rain was particularly problematic. It made surfaces slick and dangerous, reduced visibility, and made certain tasks impossible or unsafe. Heavy rain sometimes halted work entirely, sending workers home or to shelters to wait for conditions to improve. Light rain was endured, with workers wearing oilcloth coats to stay dry while continuing their tasks, though wet conditions always slowed progress and increased risks. The workers became attuned to the weather, watching clouds, feeling wind shifts, learning to anticipate when conditions would turn bad so they could secure materials and reach safe positions before storms arrived. The workers were paid daily or weekly wages that varied depending on skill level and the specific work being performed. Experienced riveters and fitters earned more than general laborers. Workers who performed particularly dangerous tasks sometimes received hazard pay, additional compensation for accepting greater risk. The wages were modest but steady, which was valuable in an economy where many workers faced uncertain employment and seasonal layoffs. Working on the tower provided income that men could count on, allowing them to support families, pay rent, buy food, and meet their basic needs. For some, it was the best job they had ever had. For others, it was simply work that needed doing and that they were capable of doing well. Despite the safety precautions, the work was physically punishing. Men ended each day exhausted, muscles aching from climbing and lifting, hands calloused from gripping tools, faces weathered from exposure to sun and wind. The constant physical demands took their toll over weeks and months. Some workers could not sustain this level of exertion and left for less demanding employment. Others adapted, their bodies growing stronger, becoming capable of feats of strength and endurance they might not have believed possible when they first started. They became hardened to the work, able to climb hundreds of stairs without becoming winded, to work all day at heights without experiencing the vertigo that would incapacitate most people, to handle heavy tools and materials with practiced ease. There was pride in the work, though it was rarely expressed openly or dramatically. These men were building something extraordinary, something that would be famous and that would last. They could see their contribution taking shape day by day, the tower rising beneath their efforts. When they walked through Paris, they could point to the growing structure and know, truthfully, that they had built it. This pride sustained them through difficult days and dangerous moments, providing a sense of meaning beyond the simple exchange of labor for wages. They were creating something that mattered, something that would outlast them, something that their grandchildren might see and know that their ancestor had helped to build. The foremen and supervisors who managed the workers occupied a middle position between labor and management, responsible for ensuring that work proceeded according to schedule and specifications while maintaining good relations with the workers whose cooperation was essential. Good foremen earned respect by being fair, knowledgeable about the work, and willing to listen to workers' concerns and suggestions. Poor foremen created resentment and could slow progress through their own incompetence or through harsh treatment that made workers less willing to put forth extra effort. Eiffel chose his supervisors carefully, understanding that the quality of leadership at this intermediate level would largely determine whether the project succeeded or struggled. As the tower rose higher through 1888 and into 1889, working conditions became more challenging in some ways. Wind was stronger at elevation, sometimes making it impossible to lift or position pieces safely, forcing work to stop until conditions calmed. The climb to work areas grew longer, consuming more time and energy at the beginning and end of each day. The sense of exposure increased, though experienced workers learned to manage their fear, to trust the structure and safety equipment, to focus on the task at hand rather than on the dizzying drop below. The view expanded as the tower climbed, eventually encompassing all of Paris spread out in every direction, though most workers were too busy during work hours to stop and appreciate the vista. When the tower finally reached completion in March 1889, the workers who had built it could look at the finished structure with justifiable pride. They had spent nearly 2 years climbing, lifting, positioning, riveting, building something that had never been built before. Their labor was inscribed in every rivet, every beam, every connection. The tower stood because they had made it stand, through skill and effort and courage applied day after day, piece after piece, until the work was complete. Though their names were not recorded in newspapers, though history would remember Eiffel and forget them, they knew what they had accomplished. They had built the Eiffel Tower. When they gathered in cafes after work or walked through their neighborhoods on days off, when they pointed to the tower visible above the rooftops and said, "I built that," they were stating a simple truth. Their hands had shaped this monument. Their strength had lifted it into being. Their patience had sustained it through 2 years of methodical construction. The tower was theirs in a way it could never belong to those who had merely observed or criticized or applauded from a distance. As the tower approached completion in early 1889, attention shifted from construction to preparation for the opening of the Universal Exposition. The tower was meant to be the exposition's centerpiece, its most dramatic attraction, the structure that would draw visitors and generate excitement. But a tower alone was not enough. It needed to be accessible, to offer experiences beyond simply being looked at from the ground. Elevators had to be installed and tested. Platforms needed finishing work to make them suitable for public use. Restaurants and viewing areas had to be prepared. The tower needed to transition from construction site to visitor destination. The elevator systems were engineering challenges in themselves. Lifting passengers safely to heights of 60 meters, 115 meters, and nearly 300 meters required reliable mechanical systems that could operate repeatedly throughout each day without failure. The elevators designed for the tower used hydraulic power, with water pressure driving pistons that pulled cables attached to the elevator cars. The systems were complex, requiring pumping stations, pressure accumulators, and carefully designed cable arrangements. Different elevator systems served different sections of the tower, with passengers transferring between cars at the platforms. Installation of the elevators took months, proceeding in parallel with the final construction of the tower's upper sections. The machinery was heavy and had to be positioned carefully. The elevator shafts were integrated into the tower's legs, using the diagonal spaces within the iron framework. Rails were installed to guide the elevator cars. Safety systems were added to prevent cars from falling if cables failed. Everything was tested extensively before being approved for passenger use. The stakes were high because elevator failures could cause injuries or deaths that would devastate the exposition and destroy the tower's reputation. The first platform, at 57 meters, was developed to include restaurants where visitors could dine while enjoying views of Paris. The iron framework was enclosed partially with glass and decorative elements, creating spaces that were protected from wind and weather while still feeling open and airy. Tables were arranged to maximize the number of diners who could have window views. Kitchens were installed with equipment suitable for the volume of meals that would need to be prepared. Staff were hired and trained in the weeks before the exposition opened. The second platform, at 115 meters, offered another restaurant and more viewing space. This level was higher and more exposed, with winds that could be strong on breezy days. The railings here were built higher and stronger, ensuring visitor safety. Telescopes were installed so that visitors could examine distant parts of the city in detail. Informational displays explained what could be seen in each direction, identifying landmarks and explaining the geography of Paris and the surrounding region. The top platform, nearly 300 meters above the ground and accessible only by elevator, was smaller and more intimate. It offered the ultimate vantage point, a place where visitors could stand higher than anyone in Paris had ever stood before. The experience of reaching this height was extraordinary, offering views that stretched for dozens of kilometers on clear days, showing Paris as a unified whole rather than as separate neighborhoods encountered at ground level. The top platform became the most desired destination, the height that visitors most wanted to reach, even though the journey required patience and often involved waiting in long queues. Finishing work on the platforms and preparing the tower for visitors continued through March and into April 1889. Workers installed lighting so the tower could be safely used after dark. They painted identification numbers and directional signs. They tested all the safety railings and barriers. They rehearsed emergency procedures in case something went wrong during the exposition. Nothing was left to chance. The tower needed to be not just impressive but safe and functional, capable of handling thousands of visitors daily without incidents that would create panic or negative publicity. On March 31, 1889, the tower was officially declared complete. Eiffel climbed to the top platform with a small group of officials and journalists, making the ascent using the stairs since the elevators were not yet fully operational. The climb took considerable effort, over 1,700 steps from ground to summit, but it was important to demonstrate that the tower had reached its full height and was structurally complete. At the top, Eiffel unfurled a French flag, symbolically claiming the height for France. Guns were fired in salute from below, though the sound barely reached the platform through the wind and distance. The completion was noted in newspapers with a mixture of admiration and continued skepticism. The tower was undeniably impressive, taller than anything yet built, a demonstration of engineering capability that could not be dismissed. But it was also undeniably strange, this enormous iron framework rising from the heart of Paris, unlike anything that had existed before. Opinions remained divided. Some praised it as a triumph of modern engineering and a symbol of progress. Others continued to find it ugly and inappropriate, a blight on Paris's traditional beauty. The tower itself was neutral to these opinions, standing regardless of what people thought about it. When the Universal Exposition opened on May 6, 1889, the tower immediately became its most popular attraction. Visitors lined up for hours to ride the elevators, eager to experience the height and the views. The queues stretched across the Champ de Mars, organized by exposition staff who managed the flow of people and sold tickets. Despite the waits, people were patient, understanding that this was a once-in-a-lifetime opportunity to experience something unprecedented. The elevators ran constantly during operating hours, carrying load after load of visitors upward, creating a steady stream of people ascending and descending throughout each day. The views from the platforms exceeded what most visitors expected. Paris from above was revealed as a coherent geographic whole rather than as a confusing collection of streets and buildings. The Seine's path through the city became clear. The radial pattern of Haussmann's boulevards could be seen and understood. Landmarks that seemed separate at ground level were revealed as neighbors. The city's relationship to the surrounding countryside became visible, the way urban density faded gradually into fields and forests. Visitors spent considerable time at the railings, trying to identify their own neighborhoods, pointing out places they knew, marveling at the perspective that height provided. The restaurants on the first and second platforms did brisk business, serving meals to visitors who wanted to extend their time on the tower and who enjoyed the novelty of dining at such heights. The food was good if not exceptional, the main attraction being the location rather than culinary excellence. Visitors lingered over meals, savoring not just the food but the experience of being suspended in air above the city, of dining in a place that had not existed until a few months earlier. The restaurants became social destinations, places where being seen mattered as much as the meal itself. By the time the exposition ended in October 1889, nearly 2 million people had visited the tower. This far exceeded initial expectations and demonstrated the tower's commercial viability. The admission fees generated significant revenue, helping to repay Eiffel's investment and proving that the tower could be financially self-sustaining. The crowds were diverse, including Parisians seeing their city from a new perspective, French citizens from the provinces visiting the capital for the exposition, and foreign tourists drawn by the fair and by reports of the extraordinary tower. The tower's success during the exposition created momentum for its preservation. The original agreement had specified that it was temporary, to be dismantled after 20 years. But the financial success and popular enthusiasm made destruction seem wasteful. Why demolish something that people clearly valued and that was generating substantial income? Arguments for preservation began to emerge, though the question would not be definitively resolved for many years. For now, the tower had proven itself during the exposition, and that success bought it time to demonstrate whether it deserved permanent status. As autumn arrived and the exposition closed, Paris settled into a new normal that included the tower. Visitors continued to come, though in smaller numbers than during the fair. The tower remained open, its elevators running, its restaurants serving meals, its platforms offering views. It had become part of the city's attractions, something that visitors wanted to see and experience. The controversy that had preceded its construction had not disappeared entirely, but it had quieted significantly. The tower existed, and existence itself was a powerful argument for acceptance. The copper that had been bright and reflective when the tower was completed began slowly to oxidize, gradually developing the patina that would eventually turn green. This oxidation was natural and expected, a chemical reaction between the copper and the atmosphere that created a protective layer on the metal's surface. The color change would take years to complete fully, but it was already beginning by the end of 1889. Starting with subtle darkening that would gradually shift toward the green that people would come to associate with the statue. The tower's appearance was beginning its slow transformation, from new metal to weathered monument. As the first winter approached with the tower standing complete, Paris experienced its newest landmark in different conditions than the summer crowds had known. Winter brought cold that made the iron contract slightly, creating tiny adjustments throughout the structure as metal responded to temperature. The wind, always present at height, became harsher, carrying rain and occasionally snow that settled briefly on the ironwork before melting or being blown away. The tower endured these conditions without difficulty, its design accounting for thermal expansion and contraction, for wind loads that varied with seasons, for all the challenges that outdoor structures must withstand. Visitor numbers declined in winter, as cold weather made the climb and the exposed platforms less appealing. But the tower remained open, its elevators running for those who braved the chill to experience winter views of Paris. The city looked different in winter light, softer and more muted, with shorter days that brought early darkness and created opportunities to see Paris illuminated by gas lamps and the first electric lights that were beginning to appear in some neighborhoods. The tower offered a vantage point for observing these changes, for seeing the city transform from day to night, from bustling activity to quiet repose. The tower's role in Paris's life began to evolve beyond simple tourism. It became a meeting place, a landmark that people used to give directions or describe locations. Near the tower became a meaningful phrase, situating places in relation to a structure that was visible from much of central Paris. Artists began incorporating the tower into their paintings and drawings, no longer as a curiosity or novelty but as an established part of the cityscape. Photographers captured it from every angle and in every season, building a visual archive that documented how the tower looked in different lights and conditions. Scientific uses for the tower began to be explored. Its height made it valuable for meteorological observations, with instruments installed at various elevations to measure how temperature, pressure, and wind varied with altitude. The data collected contributed to understanding atmospheric conditions and improving weather forecasting. Eiffel himself conducted experiments using the tower, including studies of air resistance by dropping objects from different heights and measuring their fall times. These scientific applications helped justify the tower's existence beyond tourism, showing that it could serve practical purposes that benefited knowledge and understanding. Radio technology, still in its infancy in the 1890s, would eventually provide the most important practical justification for preserving the tower. The height was ideal for radio antennas, allowing transmissions to reach much farther than ground-based systems. Military and civilian communications would both benefit from the tower's use as a radio platform. These applications would develop over the following decades, but the potential was already becoming apparent. The tower's utility for radio communications would ultimately save it from demolition, transforming it from temporary exposition structure to permanent communications infrastructure. Through the 1890s and into the early 20th century, the tower remained a topic of debate and discussion. Some Parisians continued to dislike it, finding it ugly or inappropriate for the city's aesthetic character. Others had grown accustomed to it or even fond of it, appreciating its boldness and the way it announced Paris's commitment to modernity and progress. Visitors continued to come, riding the elevators, dining in the restaurants, taking photographs, experiencing the views. The tower settled into its role, no longer novel but not yet entirely accepted, existing in a kind of limbo where its future remained uncertain. The 1909 deadline, when the tower was supposed to be dismantled according to the original agreement, approached without clear resolution. As the date neared, arguments for preservation became more numerous and more forceful. The tower had proven popular and profitable. It had become recognized internationally as a symbol of Paris. It served scientific and communications purposes that were valuable. Dismantling it would be expensive and would eliminate these benefits. The accumulation of practical justifications, combined with the simple inertia that favors existing structures, gradually made preservation seem more sensible than destruction. The deadline passed without the tower being demolished. There was no formal announcement declaring it permanent, just a quiet acceptance that it would remain. Permits were extended, maintenance continued, and the tower persisted. What had been built as a temporary structure for a 6-month exposition had become, through persistence and accumulated utility, a permanent part of Paris. The transformation from temporary to permanent happened gradually, without drama, simply through the tower's continued existence and continued usefulness. By the 1920s and 1930s, opposition to the tower had largely faded. A generation had grown up with it as part of the Paris skyline, never knowing the city without it. The tower appeared in countless photographs, paintings, and films. It had become iconic, inseparable from images of Paris. What had seemed like an alien intrusion in 1887 had become, through time and familiarity, an essential part of the city's identity. The tower that Gustave Eiffel had built as a temporary demonstration of engineering capability had become one of the most recognized structures in the world. The evening settles over Paris now, in our imagination, as it did on countless evenings after the tower was completed. The sun drops below the horizon, painting the sky in soft oranges and purples that fade gradually to deep blue and finally to darkness. The gas lamps along the boulevards are lit one by one, creating their gentle pools of yellow light. The tower stands dark against the sky, its iron framework visible as a silhouette, a geometric pattern rising from the earth toward the stars that are beginning to appear overhead. Wind passes through the iron lattice, creating soft sounds, whispers and hums as air moves through the spaces between beams and struts. The tower breathes with the wind, moving slightly, flexing in ways that relieve stress rather than allowing it to build dangerously. Everything Eiffel calculated about how the tower would behave is proven correct night after night, as the structure stands steady through calm and storm, through heat and cold, through all the conditions that Paris weather can offer. The city around the tower grows quiet as night deepens. The sounds of daytime activity fade. Footsteps echo on empty streets. Distant voices carry farther in the still air. The tower stands in this quietness, patient and permanent, a presence that will be there when morning comes, when people resume their daily routines, when Paris wakes and begins another day. The tower does not sleep, does not rest, simply exists through the night hours as it exists through the day, fulfilling its. As the night deepens and the stars will slowly overhead, the tower rests in darkness, barely visible, its presence felt more than seen. The iron has cooled from the day's warmth. The wind has calmed to gentle breezes. Everything is still and quiet. The tower stands in this stillness, patient as stone, enduring as the earth beneath it. It will be there when morning comes. It will be there for centuries to come. It stands because it was built carefully, piece by piece, rivet by rivet, by people who understood that important work requires patience and precision. And now, as you drift toward sleep yourself, you can let the tower fade from your thoughts. You can release the details, the names, the dates, the specific facts about construction and design. What remains is simply the sense of something being built slowly and well, of patience being rewarded with permanence, of human hands creating something that will last far beyond any single human lifetime. The tower stands in your imagination as it stands in Paris, a quiet presence, a testament to what can be accomplished through methodical effort sustained over time. Your breathing slows, matching the patient rhythm of construction, the steady pace of work being done correctly rather than quickly. Each breath is like another piece being positioned, another rivet being driven, another small step toward completion. There is no hurry. There is only the work, continuing at its own pace, accumulating slowly into something larger than any individual contribution. The tower rose this way. Your rest comes this way. Slowly, quietly, inevitably. The ironwork catches starlight, faint gleams in darkness. The wind whispers through the lattice, soft as breath, constant as time. The tower stands through the night, as it will stand through countless nights to come. And you can rest knowing that some things endure, that what is built well lasts, that patience creates permanence. The tower will be there in the morning. And so will you, rested and renewed, ready for whatever the new day brings. But for now, there is only darkness and quiet, only the gentle settling of thoughts, only the slow release into sleep. The tower stands. The night deepens. And you drift away, carried by the rhythm of your own breathing, by the weight of your own body sinking into rest, by the simple knowledge that the work is done, the tower is complete, and all that remains is to let go and sleep. Good night.